All right, so we've learned about Pythagorean theorem. So remember, Pythagorean theorem tells us that if we have a right triangle and the legs have length A and B and the hypotenuse has length C, right, the diagonal, then I know that A squared plus B squared equals C squared, right? We've learned that. So how can we use this to solve problems that involve circles? So this is supposed to be a nice even circle, but you can see I drew it by hand, so it's not so great. So here's a circle. The center is at the origin or point O, and there's these other 3 points, A, B, and C on the circle. So when we're solving this problem, one definition we need to know is radius, and you guys might remember this. The radius is the distance from the center to the, we can say to any point on a circle. So if you remember, let me get a different color. I'll use this pink maybe. So this, if you were going all the way across the circle, would be the diameter, right? The diameter is all the way across. So the radius would just be the distance from the middle to any point on the circle. So it's half of the diameter. The diameter is the whole way across, and the radius is halfway across. Okay, so just something to remember. So let's, we're going to use the circle, we're going to use Pythagorean theorem to find these different lengths, right, or different radiuses. So the first one says find OB. So what that means is, here's O, here's B. They're asking us to find the distance, the length of that line, the length of the radius that connects O and B. Okay, so this is line OB. So how can we find that line? Okay, well, that looks an awfully lot to me like a hypotenuse. Can I make the legs if I draw some dotted lines down and across? Yeah, I think I can, right? So I'm going to just come over here and redraw what I just did. Here's O, here's B, and then I just drew a line down and drew a line across. Now, can I get the distance of these legs? Yeah, right here. From 0, 0 out to here. The distance is 1, 2, 3, 4. So I could label this 4. And what's the height? The height is 1, 2, 3. So 4 and 3. So now I know the dimensions of the legs, and I can find OB because OB is just a hypotenuse. So A squared plus B squared equals C squared. Well, A is 4, so that's 4 squared. B is 3, so plus 3 squared equals, the C we don't know. That's our OB. 4 squared, well, that's 16. 3 squared, that's 9, equals C squared. 16 plus 9 is 25, equals C squared. Now I can solve for C, right? What's the opposite of squaring a number? It's taking the square root. Taking the square root. Square root of 25 is 5, so C is 5. Or OB, the line OB is 5. That's a not so good square round number, but right there it's 5. So I could even come up here and say that's 5. Let's try another one. What if it asks us to find OC? So let me get a different color. See what I got here. Screen. Here's O. There's C. Let's connect it. This is going to be OC. Okay, so I know I can make this a triangle by going down like this and over like that. So then when I come over here and draw that, there's O, there's C, I'm going down some, I'm going over some. Okay, so now let's count. What's the distance of this leg? 1, 2, 3. Let's label it. What's the height of this leg? 1, 2, 3, 4. Okay, so now, using my Pythagorean theorem, 3 squared plus 4 squared equals C squared. I'm noticing something that's happening here. These numbers are exactly the same, just flip-flopped around. So when I add them, I'm getting the same thing And I know C has to be 25. 25. I mean, 5, Miss Harrington. It's the square root of 25. So this has to be 5. So this length of this radius OC is 5. And the really cool thing that you'll find is that if you have to find any distance between the center and the point on the circle, the radius is always the same. So the radius of this circle, no matter where I put that point, is always 5. And I could check, like, what if I wanted to find the radius from here to here? Well, I can count that. 1, 2, 3, 4, 5. Yeah. So this circle, the entire circle, has a radius equal to 5. It doesn't matter where we put the point. All right, you're going to try some problems like this today too. See you next time.